Hello everyone, welcome to Technogate. Now we'll be starting a new topic, a new subject, that is the irrigation engineering. So in this lecture we'll talk about the basic introduction of the subject, why this subject is studied in civil engineering, and what is the scope of this subject. What is the practical application? Scope means basically the practical application of the subject. So let us start our discussion. In this lecture I'll also tell you the definition of irrigation also. What is the definition of irrigation? What is the meaning of irrigation? Everything I'll tell you. Now let us start our discussion. And before starting the discussion, let me tell you one more thing, that this subject, that is irrigation engineering, is not the core subject of civil. You must have studied many subjects in civil. Some subjects are related to structures, that is strength of material, RCC, steel, soil mechanics, transportation engineering, then your fluid mechanics, many more subjects you study. Every subject has its own importance. As a civil engineer, definitely the most important subjects are the subjects in which include the designing of the structure. It can be RCC for the concrete structure, it can be steel for the steel structures, strength of material, the very basic subject to understand the structural behavior of a particular building or a particular you can say structure. Also theory of structures, or in some universities it is also known as the structural analysis. That is also an important subject as far as civil engineering is concerned. Practical applications are concerned. But this subject, irrigation engineering, is not a core subject. I'm not talking that it is not important. What I'm saying is this subject is not a core subject of civil, because as a civil engineer I am having no concern with the types of crops, the season in which a particular crop is sown, a season in which a particular crop is harvested. That is not our role of a civil engineer. But still this subject is studied as a syllabus or as a curriculum of civil engineering in almost every university of India. So the question is, why we study irrigation engineering? So let us start our discussion from this point only, the practical meaning of this subject and why this subject is a part of civil engineering curriculum. So let us start our discussion with a very basic term, that is rainfall. Although I am not going to tell you about the definition of rainfall or the types of rainfall, that we'll be discussing in the concerned related chapter, in the upcoming chapters. But because in this lecture we have to understand the practical significance of this subject, why we study this subject, therefore let us start our discussion with the term rainfall. And I am 100% sure that every one of you know the meaning of rainfall. I am not talking about the definition, I am not talking about the technical aspects of this particular term, but the meaning of rainfall is clear to everyone. Now the question is, for example, I give you a very basic or a practical example. Suppose there are two cities, city A and city B. Means two different locations. Now I am saying at 10 a.m. in the morning. Example, at 10 a.m. in the morning, can I be 100% sure that both the cities are not receiving rainfall, or both the cities are receiving rainfall at 10 a.m.? Is it a guarantee that at a fixed time, at a particular time, these two locations are going to get exactly same amount of rainfall? Definitely the answer will be no. Getting the point or not? What I have done, I am not talking about the definition of rainfall. What I am saying is, there are two locations, city A and city B, and at a fixed time, let us say 10 a.m. Is it true that both the cities will be receiving equal amount of rainfall, or is it true that both the cities are not receiving rainfall at 10 a.m.? The answer to both the questions will be no. It is not a guarantee that both the cities will be receiving exactly same amount of rainfall at a fixed time. 100% true. Now second example. Let me take a particular city A, and in this city I am talking about two different times, 10 a.m. and let us say 12 a.m. So what are the two examples? This was example number 1 and this is example number 2. What are the two things? In example number 1, I have taken two different locations and a fixed time. In example number 2, I have taken a fixed location and two different times. Getting the point? So the first thing that I want that we need to understand and we need to discuss is at a fixed time. At a fixed time, the rainfall in two different locations may or may not be same. Yes or no? So can I write the conclusion? The conclusion can be at a fixed time. At a fixed time, rainfall at two different locations may or may not be same. Very clear. Time is fixed, locations were different. At a fixed time, rainfall at two different locations may or may not be same. The same thing can be written for this. At a fixed location, rainfall may or may not be same at two different times. So what can be the conclusion for the second example? At a fixed location, rainfall may or may not be same at two different times. That means what is the conclusion? The conclusion is rainfall depends on location as well as time. Rainfall is a function of location and time. Rainfall will change with the location. Rainfall will also change with the time. Correct or not? From these two examples, it is very clear that the rainfall pattern will depend on the location, because with the change in location, the rainfall pattern may or may not be same. At the same location at different time, rainfall pattern may or may not be same. The conclusion is rainfall is not uniform over the entire earth, or let us talk about our country only. Rainfall is not uniform. The pattern, the behavior of the rainfall is not same in our entire country. Rainfall changes with location, rainfall changes with time. Correct? So what is the conclusion from these two statements? Conclusion is rainfall pattern changes with time and location. Rainfall pattern changes with time and location. With the change in time, the rainfall pattern will change. With the change in location, the pattern of rainfall is going to change. I hope this is clear. Now, if this is clear, then it is also clear, it should also be clear. In short, I can write rainfall pattern is uneven. The rainfall pattern is uneven. It is not same over the entire location at the entire location, and it is also not same at different time zones. Now, if this is the situation, therefore I cannot rely 100% on the rainfall, because it is not same. For example, I am living in a particular area. Let us say I am living in central India. Another person is living in northern India. Another person is living in the eastern part of the India. Definitely the rainfall pattern at all these three locations are going to be different. The east part of the country, the eastern part of the country definitely receives a very high rainfall. Meghalaya, Assam, Tripura, all these states of the country receives very high amount of rainfall. If you talk about the westmost part of our country, Rajasthan, it receives very less rainfall. Madhya Pradesh, average rainfall, not very high, not very less. Northern part of the countries, Delhi and above Delhi, receives very high rainfall. So the rainfall pattern is different over the entire country. That means if the rainfall pattern is different, I cannot rely completely over the rainfall. I need some water for my use. If the pattern of the rainfall over the entire country was same, if every day at a fixed time I get a rainfall in my city, example, it is not true, it is not practically true, but assume an ideal situation. If every day from 8 a.m. in the morning to 9 a.m. in the morning for fixed 1 hour daily I am receiving a rainfall, then I will not have to rely over any other source of the water. But this is not true. Therefore, I cannot rely completely on the rainfall. The similar thing happens with the plants and crops also. Plants and crops are also the living beings. As we are the living beings, plants and crops are also the living beings, living things. They also require water for their growth. But the rainfall pattern is not uniform. A particular area of the country is not going to receive a rainfall every day for the entire year. Never, never, ever. So the plants and the crops that are grown in that city, the growth of those plants at a particular area cannot be relied only with the rainfall of that area. Definitely I will require some extra water apart from the rainfall, because rainfall was not uniform, and if rainfall is not uniform, I cannot rely completely on the rainfall for the growth and productivity of my plants and crops. So what I have to do, when there is no rainfall, then I have to supply water to the plants, and that supply of the water to the plants is called irrigation. Irrigation is not the thing. The water that is received from the atmosphere in the form of rainfall is not irrigation. Apart from the rainfall, the water that is supplied by us to the field, to the agricultural fields, that water's application, that water supply is actually known as irrigation. Now understood what is the basic meaning of irrigation and why irrigation is important? Because rainfall is not uniform. If every day I am receiving a rainfall for a fixed duration, for 1 hour or 2 hour duration, there will be no need of any other water source for us, neither for us, neither for the plants. But the rainfall pattern is not uniform, therefore neither the needs of the human being nor the needs of the plants can be fulfilled only with the rainfall. We need some extra water. When there is no rainfall, during that time I need some extra water for my growth and for the growth of the plants. So the extra water apart from rainfall that is supplied to the fields for the plant and the crop growth, that application of the water is called irrigation. So what is irrigation? Let us define the meaning of irrigation. What is the definition of irrigation? The definition is artificial. Artificial means manual application of water to the fields for crop growths. Is called irrigation. Artificial means not natural. the field, the irrigation field, the agricultural field will be receiving some natural water also in the form of rainfall from the atmosphere. But that water is not considered as irrigation. Irrigation is the water that is supplied by us. We are going to supply this water to the field, and that application of the water to the field, apart from rainfall, rainfall is never considered as the part of irrigation, because the rainfall that is being received in a particular area, that rainfall is not sufficient for the plant growth, for the crop growth. We need some extra water for the growth of the crops, and that extra water has to be supplied by us. So the method of the application of the water to the field, artificial, that is the manual application of the water to the field, is called irrigation. Got the point? The meaning of irrigation now must be clear to everyone. But the question is still in front of us. As a civil engineer, why we are concerned with the crop growth? The growth of the crops and the cultivation of the crop is the part of farmers. As a civil engineer, we are not going to grow the crops. So as a civil engineer, what is the meaning of studying this subject? See, I have to supply water to the field. Manual application means I and you have to supply water to the field. Now, what is the role of civil engineer in supplying this water? Definitely this water must be brought from some water source, from some water body. It can be a river, it can be anything. So how to bring that water from the river to the field? Through the canals, by constructing the dams, by constructing the hydraulic structures like weir and barrages, by constructing the canals, branch canal, main canal, distributory canals, number of canals we have to construct. Because what we have to do, we have to manually supply the water to the field. From where this water will come? Definitely this water will come from any water body. It can be a river, a big lake, something like this. So how to bring the water from the river to the agricultural field? Definitely I'll have to construct a, maybe possible I have to construct a dam, I may have to construct a weir, I may have to construct a barrage, I may have to construct the canals. All these things we'll be studying in this subject. So the construction of dams, who is going to construct the dams? You and me. Who is going to construct the canals, weirs and barrages? You and me are going to construct these structures. So why irrigation is studied? Because irrigation definitely means the manual application of the water. But how this water will be brought to the field? This water will be brought to the field by constructing the hydraulic structures. And wherever a word construction comes, definitely the role of civil engineer starts from there. Therefore, it is important for us to study irrigation engineering also. I hope the meaning is clear. Now let us discuss the scope of irrigation engineering. What is the scope of irrigation engineering? Let us discuss. Scope of irrigation. What is the scope of irrigation? Scope means what is the practical applications of irrigation? What is the practical significance of irrigation? Scope means you can say practical significance. Practical significance of irrigation. So I will be defining, or I will be explaining you the practical significance in three different parts. So the scope of irrigation can be divided in three parts. The first scope, or the first practical significance, I am writing it as the engineering scope. Which is important for us as a civil engineer. This scope is important because we are the engineers, and because we are studying irrigation engineering, the study of irrigation engineering as a civil engineer is only due to this practical significance. So the first scope is engineering scope. I'll discuss in detail. The second scope is the agricultural scope. Agricultural scope. And the third scope is the managerial or management. The third scope is the management scope. So how to study or how to analyze the practical significance of irrigation? The practical significance or scope of irrigation can be studied in three different parts: engineering practical significance, agricultural practical significance, and practical significance related to management and operations. So let us discuss one by one: engineering scope, agricultural scope, and management scope. I hope the things are getting very clear to everyone. Now let us start with engineering scope. So why, as a civil engineer, just now I have discussed with you, as a civil engineer, what is the practical significance of this subject? Why I have to supply the water to the field from the river or from any water body. So definitely I'll have to construct some dams, I'll have to construct the canals, I'll have to construct the weirs, barrages, many hydraulic structures needs to be constructed. And all these things will be constructed by a civil engineer. So the practical significance of this subject from the engineering point of view is, the first is construction of hydraulic structures. STRS means structures. Construction of hydraulic structures. Example, dams, weirs, barrage, many other. We'll discuss in the upcoming chapters, in the upcoming lectures. We are going to discuss the concepts of dams, weirs, barrages, everything we'll be discussing. So we have to, as a civil engineer, we have to construct the hydraulic structures to supply water to the field. Similarly, I'll have to construct the canals also. Construction of canals, correct? How much water I'll have to supply? What is the design discharge? This canal, definitely I will be constructing a canal, but this canal will carry how much amount of water? That also I'll have to decide. As a civil engineer, I have to decide the design discharge for the canals. How much amount of the water needs to be supplied? That means supply of water to the field. Supply of water to the field. How much water I have to supply? That I'll have to calculate. Farmer do not know the formula discharge is equal to area into velocity. The farmer who is cultivating the crop in the field does not know the concept of discharge. He do not know how to calculate the discharge. He know how to supply the water. He know how to supply the water to wheat, how much water needs to be supplied to rice, that he knows. But what amount of water will be carried by the canal? That means the discharge. How much discharge will be carried by the canal? Discharge is equal to area into velocity. Farmer do not know to calculate the discharge. How to calculate the area, how to calculate the velocity, how to calculate the design discharge, that will be done by us. Apart from this, wherever our irrigation project is constructed, wherever dams, weirs, barrages are constructed, definitely hydroelectric power plants are also constructed over there. Hydroelectric power plants. Wherever a dam is constructed, 90% of the gravity dams in our country includes the hydroelectric power plant construction or includes the hydroelectricity power generation. What is hydroelectricity power? How the plants are being set up? That is that part of discussion when we will be discussing the concept of dams. There I'll tell you hydroelectric power plants, details of hydroelectric power plants also. So as a civil engineer, this is the scope of irrigation engineering. Why we study irrigation engineering as a civil engineer? If someone asks you, everything is not important for the exam. Everything will not be asked in your competitive exam. But because you are a civil engineer, you need to understand the practical significance of each and every subject that you have studied in your university, in your college. Every subject has its own practical significance. It can be fluid mechanics, it can be irrigation, it can be soil mechanics, it can be transportation, RCC, strength of material, theory of structures, steel structures. Every subject that you have studied or you will study, every subject has its own practical significance. And it is important. Everything that you are going to study, it is not necessary that everything will be asked in your exam. But because you are studying a subject, you have to study the subject not only for your exams, but to understand the practical applications, practical significance of that subject also. So these are the practical significance of the subject, that is irrigation engineering. Practical significance on the basis of engineering point of view. Because we are engineers, so we have to deal with all these things only. But apart from engineering scope, another scope was the agricultural scope. Another scope is agricultural scope. So from the agriculture point of view, what is the significance of this subject? I have to grow the crops. Now forget about civil engineering. The role of civil engineers was this one. But now think of a person who is directly related to agriculture. So as an agriculturist, what is the first thing that I need to do? I have to prepare a land for growing the crops. Correct? So the first is land preparation. Land preparation for cultivation of crops. Cultivation means growing of crops. Land preparation for cultivation of crops. Now I have prepared a land, and over this land which crop needs to be grown? Will it be a rice? Will it be a wheat? Will it be a gram? Will it be a sugar cane? Will it be some potato, tomato, anything? Which crops need to be grown in a particular season? As a civil engineer, I am not interested in this thing. As a civil engineer, I am not interested that during the monsoon season wheat is grown, during the summer season any other crop is grown. I am not interested in this. Who is interested? A person who is directly associated with the agriculture. So the second is understanding the crop pattern, understanding the type of crop that should be grown on a particular land in a particular season. Type of crop which should be cultivated or grown, anything you can write, cultivated in a season. For example, this is the season. This is the monsoon season, for example. In the upcoming months, mainly during I think after this monsoon season, most probably in October, wheat will be cultivated in almost every part of our country. Wheat will be sown, wheat will be cultivated, and it will be harvested in the next year in the month of March. So as a person who is directly related to agriculture, he need to understand at a particular season which crop should be grown. Third thing, he also should know about how to increase the fertility of the soil. As a civil engineer, we also study soil, but we never talk about the fertility of the soil. we talk about the bearing capacity of the soil as a civil engineer. So we are not concerned with the thing that whether a soil is fertile or not as a civil engineer. We are concerned with the bearing capacity of the soil because I want to construct a structure over there. That is a civil engineering aspect. But if we are talking about soil on the agricultural point of view, so a farmer will not be concerned with the bearing capacity of the soil. The farmer will be concerned with the fertility of the soil. Correct? So from the agricultural scope, what will be the third significance? Will be how to increase the soil fertility. Increasing the fertility. I have to increase the fertility of the soil. I have to understand the type of soil, not the type of soil according to the civil engineer key. Farmer do not know the meaning of Indian standard soil classification. A person who is directly associated to farming, a person who is directly associated to agriculture has nothing to do with the type of soil. Clay, silt, gravel and sand. He do not know about the particle size distribution analysis. He do not know about the plasticity chart. He do not know about the liquid limit, plastic limit, shrinkage limit of the soil. What he knows? Type of soil on the basis of which soil is suitable for which type of crop. For example, in central India, everywhere you will find black cotton soil. Now, as a civil engineer, if I talk about black cotton soil, I'll say that this soil is having the least bearing capacity. But the farmer is not concerned with the bearing capacity. Farmer will say that the black cotton soil is very good for cultivation of cottons and for cultivation of soya bean. And it is also very good for the cultivation of wheat also. So see, the thing is same, black cotton soil. But as a civil engineer, what I'll be seeing in black cotton soil? I'll be seeing that black cotton soil contains a mineral montmorillonite, and due to the presence of montmorillonite, this particular black cotton soil is having a swelling nature. It is having a shrinkage nature, and the bearing capacity of black cotton soil is very less. This is what I will see for a black cotton soil. But when a farmer will see a black cotton soil, what he'll say? When the farmer will see a black cotton soil, he'll say that this soil is very good for the cultivation of wheat, for the cultivation of cotton, and for the cultivation of soya beans. I hope you are getting the point. See, the thing is same, but the view of a civil engineer and for a farmer is different for a same thing. I am also, as a civil engineer, I am also seeing a black cotton soil. The farmer who is standing behind me, who is standing along with me, is also seeing the black cotton soil. But the way in which I will be seeing the black cotton soil will be totally different from the way in which the farmer will be seeing that soil. I will see the soil on the basis of its bearing capacity. Farmer will see the soil on the basis of its fertility and suitability for the crop growth. So the fourth will be type of soil, or it's better to write suitability of soil. Suitability of soil for crop growth. Suitability of the soil for crop growth. Correct. Similarly, there are few more aspects from the agricultural point of view. The land over which I have to cultivate a crop, suitability of soil, and if for example, every one of us are residing in a particular colony, in a particular area. Correct. In your city, you will be residing definitely in a colony, in a society, in a particular area, in a particular apartment. Correct? Was that land suitable for crop growth? No, because there was the construction of structures over there. So as the suitability of the soil should be decided, similarly the suitability of the land should also be decided. Whether if I cultivate a crop in between the city premise, for example, I'll tell you, for example, this is a physical map of a city and this entire portion is the residential area. Definitely I will not be growing my crops in this area. I will use this area for the cultivation of my crops. So I'll have to decide the suitability of the land also for agriculture. Suitability of land for agriculture. For farming you can also write. Not necessary that agriculture, you can write suitability of the land for farming. So these are some of the agricultural scope of irrigation engineering. The last is the management, the scope related to management. The third is the management scope. Engineering scope, agricultural scope and management scope. See, whenever you perform any task, any task, whether it is related to your engineering, whether it is related to your routine work, whether it is related to any work of your home or your family, everything requires management. If I have to construct a dam, it will require a management. If I have to construct a canal, it will require a management. If I have to supply the water to the field, it will also require a management. If a farmer has to prepare a land, it will also require some management. If I have to grow a particular crop, it will also require a management. Whether a land is suitable, whether a soil is suitable for a particular crop or not, this will also require a management. Every single task, whether the task is of your routine work, whether the task is related to your college work, whether the task is associated with your professional life, every task of your life requires management. The same thing is here. So whether it's an engineering scope, whether it's an agricultural scope, whatever has been written over there, every point needs a proper management. That is what is the managerial scope. If I have to construct a canal, definitely the canal will be constructed by a civil engineer. But during the construction, I'll have to manage the things. I'll have to manage the labor. I'll have to manage the material. I'll have to manage the time in which I have to construct that canal. Similarly, if a farmer is preparing a land for the cultivation, he has to, for example, he has to start the farming from the month of October. So definitely he'll have to prepare a land before the starting of the month. That is the management. To increase the soil fertility, a farmer has to increase the soil fertility. How he'll increase? Definitely he'll adopt some, he'll be having some management with him. Time management or many other type of management can be there, but it is I hope this is very clear to everyone. Every task, whatever is written over here, every task requires a proper management, and that is the management scope. So I hope the meaning of irrigation, definition of irrigation and scope of irrigation is clear to everyone. This was the basic thing, because we are starting a new topic, we are starting a new subject. Therefore, it is very important for us to understand the meaning, the practical significance of that subject. So this is what we have discussed in this lecture. In the next lecture, we'll again discuss, we'll discuss the advantages of irrigation, disadvantages of irrigation and types of irrigation. That will be the thing that we'll be discussing in the next lecture. Thank you.